This is the video for Lesson 5 from the Grade 8 Module 2 book, found on page 19. So in this one, we're going to get into the transformation known as rotation. Rotation when you spin something. So with rotation, there are some things we need. We need a point to rotate around and a degree of rotation. Remember, that means to spin, so we have to know how far to spin and what to spin around. All right, so let's get into it with exercise 1. Exercise 1 says, let there be a rotation of d degrees around center O. Let point B, or let P be a point other than O. Select D so that D is greater than or equal to 0. Find P prime, in other words, the rotation of point P, using a transparency. We are not going to be using a transparency today. Okay, so let's identify something first. Well, the first thing we have to identify is the point to rotate around. They give us that point right here. They say that we're rotating around center O. We can see that point right here. So that's the point we're rotating around. We also need a degree measurement to rotate. They didn't give us a specific number. They gave us d, which is a variable, and they just said that d has to be greater than or equal to 0. Let's do this. Let's let d equals 90 degrees. We had to pick some degree measure that was greater than or equal to 0, so 90 fits the bill. So we're going to rotate this point P 90 degrees around O. Here's what we need to do. First thing we need to do is get out our ruler, measure the distance straight from the point of rotation to the point that we are rotating. So there we go. Having a little bit of trouble with my ruler. 80 degrees seems about right. Ooh, there we go. Okay, so looking at this, I noticed that my ruler, let's see, 10, 20, 22. So it's at 22 dash marks on my ruler right now. Again, your ruler in real life will probably have a different measurement. I want to make sure that the distance from the point of rotation to the point P, the point that's being rotated, stays at that 22 dash mark, stays at that same distance. Now, I did say that we're going to let D equal 90 degrees. So that's a positive number. When it's a positive number, we rotate counterclockwise, meaning we are going to spin in this direction. Think of like how an old school clock goes, the way that the second or the minute or the hour hand ticks around is clockwise. The opposite of that, meaning starting at the top and going down to the left, would be counterclockwise. So bringing my ruler back up, let's see what happens when we rotate this 90 degrees. So I'm starting at 80. That means I want to actually go down to 0 and then 10 more, but I'm going to keep my distance the same. So I'm rotating, let's see, there we go. Oh, trying to keep it on my point there. There we go, 10. So I just rotated 80 degrees. I need to rotate 10 more. There we go. That's a rotation of 90 degrees. Now I want to measure that those 22 dash marks. So 10, 20, 22 is right about there. So P prime will be right about there after I rotate 90 degrees, which means 90 degrees counterclockwise. All right, simple enough. Let's keep going. 2 says let there be a rotation of d degrees around center O. Okay, same type of deal. Let P be a point other than O. Select D so that D is less than 0. So that's the difference here. Let's say this. Let's let D equal negative 90 degrees. So if a positive 90 degrees means you rotate counterclockwise, negative 90 degrees means you rotate clockwise. So let's kind of see where we're at now. Again, I'll put my ruler here. There we go. And again, we see it's about 22 dash marks. I need to rotate though. So I'm going to rotate this. Let's see, 90, or I'm sorry, 80. 80 rotated by 90 degrees. Let's see, there's 10. So I need 80 more to go to rotate a full 80 degrees. And there we have it. So I went from 80 to 90, so that was 10 degrees, and then 90 down to 10 degrees was another 80-degree rotation. That first 10 plus that second 80-degree rotation gives me a 90-degree rotation total. Let's see, so 10, 20, 22 brings us right there. So this would be P prime for this one. All right. Moving on down to part 3, says what direction did point P rotate when D was greater than 0, greater than or equal to 0 degrees? We could just do a one-word answer. We'll say counterclockwise. So when it's a positive degree measure, it rotates counterclockwise. In this case, D is less than 0 for exercise 4, and that would just be clockwise. So negative degrees means clockwise, positive degrees means counterclockwise. All right. Exercise 5. We got a whole bunch of stuff going on. Let L be a line, AB be a ray, CD be a segment, and angle EFG be an angle, as shown. Let there be a rotation of D degrees around point O. Find the images of all figures when D is greater than or equal to 0. So a little bit of work to do on here. First, we identify the point of rotation. Point of rotation is O. We see O down here. Maybe I'll even put a little orange with it again. All right, and we have to pick a rotation so that it's greater than 0. So let's go with 90 again. So we'll let D equal 90 degrees. All right, let's kind of go with the same steps as we learned in the original. So 90 degrees means it's going to be a counterclockwise rotation. So I'm going to go ahead, I'm going to measure the distance between each point and O. So there we have it. O, let's do A, that ray AB first. Right here, 20. No, I'm sorry, that's 10, 20, 25, and it's right about 20, we'll call it 29. So 29. So 29 dash marks to A. That means when I rotate, so let's see, it's at 59, a rotation of 90 degrees. If I went down to 0, that'd be 59, and then I would have to continue on to from 59 to 90 would be 31 more degrees. So let's go ahead and do it. So it's, again, about 29 dash marks. Rotating to 0 first. So I just made a rotation of 59 degrees. I have to go 30 more degrees to do that 90-degree rotation. So let's keep going. Another 31 degrees right there. All right, and I remember that it's 29 dash marks. And there we have it. So this point right there is A prime. Let's do the same thing for B. So B is going to be a little bit of a longer distance. All right, got that lined up. So let's see, that's 10, 20, 30, 40, 50. We'll call it 51. 51, and right now it's at 64 degrees. So if I rotate down to 0, there we go, I just rotated 64 degrees there, so I have another 26 degrees to go. There we have it. So there we go, 26 degrees, 64 plus 26 gives me 90. And I'm remembering that it was 51 dash marks from point O to begin with. So let's see. 1, 20, 30, 40, 50. Right here would be about 51. This point represents B prime. Now look, and I say, oh, this was actually a ray where A was going to be. So this also is a ray. I'm going to go ahead and connect those points to make my ray. And there we go. So I'll put my arrow at the end. Now when I rotate, I'm not changing the distance, I'm just changing the position of what it is. So my original distance, or actually my new distance, should match my original distance. Since I'm on my images ray, I might as well start there. So let's see, it is 10, 20, 23 dash marks long. Let's make sure that's what our original was. And right there, we have it. 10, 20, 23 dash marks long. So that's perfect. That's how it works. It preserves that distance. Rotating preserves the distance or the length of a ray or a line segment or a side length, whatever it is. Rotations preserve distance. Distances stay the same. So moving on, we are not going to do line L or this line segment DC, but I do want to do this angle here, EFG. So I want you to go ahead, take the same steps, measure the distance from O to G, O to F, O to E, and perform that 90 degrees counterclockwise rotation. A little trick you could do, since you don't have the nice angle measurement on your ruler. We are only rotating 90 degrees. So you could draw a line here, and that's when you have your point of rotation and your point you're rotating lined up. And when you have a see-through ruler, you can just rotate until those grid lines are in line with the line you just drew. It's a nice little shortcut. That way you know it's perfectly 90 degrees because your ruler and those grid lines, the ruler's edge and those grid lines are 90 degrees. So right there, 41 is perpendicular to, let's see what I have, to about 52. It's not perfect, but it's pretty close. Maybe it should have been 49. Anyway, not perfect, but it'll be close enough for what we're trying to do. So I'm measuring my dash marks. I see how it's, let's see, 10, 20, 30, 40, 42. I'll do that little trick I just talked about right here. I drew that line. I'm going to try to line up, there we go, my see-through ruler. And I'm going to go ahead 42. 10, 20, 30, 40, 42. Takes me to right about there. So there is my G prime point. All right, I'm going to do the rest with the others. Go ahead, do the same with yours. There we go. I got my 3 prime points now, the images of my points. I'm going to go ahead, connect them. Remembering that the vertex of this angle is F. So E and G both go to F. Like so. So we look at it and we're like, okay, well, that kind of looks like what we got, which it should. It should look like what we had originally, just in a different position. And we can tell it was kind of spun 90 degrees. Something else to check out. Let's see. If I go right here, line up this, I notice that line is at about a 6 degree, about a 6 degree slant. So 6 degree, and if I rotate it up, this line here is at a 35 degree slant. So that angle measure is about, let's see, 35 minus 6 gives us 29 degrees. On our images angle measure, this, let's see, was at about 81 degrees for that line. Rotate, it goes from 81 to about 52 there. So 81 minus 52 gives us 29 degrees. So even though it's spun, the angle measure between the two sides of this angle stayed the same. So something we want to remember is that a rotation preserves the length of a line and the angle between lines.